Fraction of light through a prism. So we will try to go through it in detail and understand about the formulas, the angle involved in it, right? Angle of deviation, angle of incidence, refraction, emergent, everything. So first of all, let's understand what is a prism. If you have not seen a prism, then this is a 3D picture you can see in it. It says it has got 5 plane surfaces. Can you imagine which are the 5 plane surfaces? One is this side, another is this side, another is this side, 3 sides, and in front here is front part, and in behind that part. So they have got 5 plane surfaces, and these 5 plane surfaces, right? Okay, okay, nothing to do with this plane here. This is the base, we call it as. This is the refracting surface, this is the refracting surface, right? And this is the edge that we have, nothing to do with the from behind here, right? So ray of light will be incident from where? If this is the plane of this refracting surface, you can draw a normal from there, and if any light is incident at this point, this is the angle of incident, and yes, it will refract, fine. This is the angle of refraction. Again, you have to draw a plane in it, fine. And this is the angle of emergent, we can call it as, fine. And then obviously you will be studying more about that in it. So what is a prism? You know, is a transparent medium of refractings. It's a transparent refracting medium bounded by 5 plane surfaces with a triangular cross section. This is the triangular cross section. You know, cross section means this is the part flat, this is the part flat, this is a cross sectional part in it. Okay. Now, what are the factors that affect the angle of deviation in it? So let's see what happens in it first, then you will understand the deviation. This is the normal, you can see. What is the normal in it? You can see the normal. This is the normal to the plane of the surface here. And angle of incident, it makes an angle. This is called angle of incidence. It get refracted. So this is if there had not been any deviation, it would have gone straight like this without deviation. You can see that part, but it gets deviated because this is a denser medium, this is a rarer medium, so it will get deviated, and it deviates and goes like this. So the angle it makes with the normal is called angle of refraction, which is termed at R1 here, and this is the angle of incident I1 here. Then after it, this is the denser medium. Now it is coming from a denser to rarer medium. Again, you will draw the normal. You can see this is the normal that we have drawn, and from the normal it will bend away from the normal. Why? Because it is from denser to rarer medium. So this is the angle of we can say inside that particular prism is angle of incidence, but here it is named as what? Angle of this is R2 in it, and then it comes out making a bigger angle. You know what is that? Angle of refraction, we can call it as, from denser to rarer. But here we have taken as I2, which is emergent, angle of emergent, we can call it as, right? This is the coming out emergent ray. So angle between the emergent ray and the normal is angle of emergent here, so which is I2 in this case here. So emergent, incident, and this is the inside one, R1 and R2 here. Now if it had not got deviated, it would have got a straight, that it had not, and then this one is the emergent ray, is coming in this way. So actually the ray would have gone this way, but it is not, but is coming this way. So is it not that it is getting deviated by? You can see, had it been gone straight, no, it is deviated by this way. So what is the angle by which it get deviated? We call it as delta, and that is called angle of deviation. In this case they have given here delta 1, delta 2. Fine, just keep it in mind, we are not deriving it, just understanding it here. Okay, so we were talking about angle of deviation here. So angle, it should have gone straight if no deviation, but is going this way, it got deviated. This is called angle of deviation, right? So the formula here for angle of deviation is I1 plus I2, that is incident ray, angle of incident, angle of emergent, add them up and subtract from that the sum of this angle of refraction 1 plus angle of refraction 2 here, and this is how you will get the deviation. And also to note down that R1 plus R2, this angle of refraction 1 plus angle of refraction 2 is equal to angle of the prism here, and I1 plus I2, incident emergent angles, is equal to A plus delta. Yes, obviously you just make a note of all of these. We can get it by deriving it. To say, what do you do at R1 plus R2? At this place, what will you put? You will put A, so it becomes I1 plus I2, right? Minus A, so minus A will go the other side, become plus A, so delta plus A is I1 plus I2. Okay, it's nothing as such. Now the factors which affect the angle of deviation, which are those? Angle of incident. If you increase angle of incident, the angle of deviation will increase, right? But there is some limitation to it. We'll talk about that some. Okay. Now the material of the prism also, if it is say less denser, then it will deviate less. If it is higher, density is higher, then it will deviate more. It depends upon the angle of prism here. So this, it depends upon this angle. So if this angle is more, see, if this angle is more, then what will happen? Basically it would be delta is equal to I1 plus I2, right, minus angle A. Is that okay? If angle A is more, then deviation will be less. If angle A is less, deviation will be more in it, because it has to be subtracted. Is that okay? Now the color of the wavelength, we know that the light which is used, it depends upon that. Violet bends the most and the red bends the least, because red has got bigger wavelength, so velocity is more. Violet has got smaller wavelength, so velocity is less, it bends the most. Okay, now coming to this, we will talk about that. Dependence of angle of deviation on the angle of incidence. What is that? Angle of deviation depends upon angle of incidence. I talked about it earlier. Now how does it do? It is experimentally observed that as the angle of incidence increases, the angle of deviation first decreases. See, you increase angle of incidence this way, and angle of deviation will decrease in it. You can see in the figure here, it decreases, right? And reaches a minimum value. It reaches a minimum value, we call that as delta minimum here. Certain angle of incident. And then you further increase angle of incident, then angle of deviation will increase in that. Okay. On further increasing the angle of incident, the angle of deviation begin to increase from here. So we call this point as minimum deviation point. So what is the angle of incident here? See, angle of incident is increasing in this way and it is decreasing. You can see it is decreasing. Value is more, less, 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 the least here. And we call the minimum deviation at that point. And then after increasing angle of incident, it will increase in that case. Is that okay? It is found that angle of deviation becomes a minimum when the angle of incident is equal to the angle of emergent. Right. So what is that? Angle delta minimum is what? When I1 is equal to I2 here. When I1 is equal to I2, right, then it is minimum here. See, it means delta is minimum only when angle of incidence is equal to angle of emergent here. Okay, clear? When they are equal, I1 is equal to I2, then only is a minimum. The position of the prism with respect to the incident ray at which the incident ray suffers minimum deviation is called position of minimum deviation. I mentioned that this is the position of minimum deviation, and it will be at a particular angle. And remember that angle of incident in that case, this angle will be same as angle of emergent in that case. Okay. Now, thus the in position of the minimum deviation, the refracted ray inside the prism is parallel to its base. Two things to be noted. This will become, this angle of incident is equal to angle of incident 2 here, right? I mean emergent here. So this ray will become parallel to the base. Is it clear? And in that situation, what is that? The deviation is the minimum there. It is increasing. See, earlier it was like this at this particular one. Okay, if you increase that, it will further decrease. Further increase that, it will become parallel. Further increase that, it will no be more be parallel. What will happen? It will decrease further. Is it clear? So that is what is happening in it. And angle of incident is, what is happening in it? Angle of incident is increasing, and when it becomes equal to emergent, it becomes parallel. After that, when the angle of incident increases, angle of deviation will also increase in it. Is that part clear? Because it will bend now. It will bend further, so it will be more. So that is what they're telling you. The position of the prism, okay, I mentioned this earlier. The position of the minimum deviation of the refractive ray inside the prism is parallel to its base, and if the prism is equilateral, then the principal section of prism forms an isosceles triangle, right? In other words, the position of the minimum deviation, right? D minimum I1 is equal to I2. I mentioned that earlier here. Now deviation at different angles of incident. When we take the angle, just take an example in it. So when we have in this figure, you can see when the angle of incident is 70 degree, you can see this is not parallel to the base. It is going in this way, and angle of emergent is 33. They are not equal here. Angle of deviation is 43. Remember this part. When we increase the angle of when we decrease the angle of incident here, 48, right? Then you can see it has become parallel to it, and this is also 48. And angle of deviation is how much? 36 in it, right? When we decrease that angle of incident here further, it was 70, more, less, least, less, further, less. You find that angle of incident is 30 degree, angle of emergent is 77 degree, and you can see it's not parallel, and angle of deviation is 47 degree here. So in which case is the maximum here? The angle of deviation more. Is this case, or this case? You can see 47 is more than 36 and 43. So angle of deviation here is when we increase the angle of what? Angle of incident increases is more, less, and less. So angle of deviation is more in this case. This is what they're giving you the figure in it, and they have explained in it what happens. So that is when this is the angle of incident, angle of incident, angle of incident. What happens at that? Clear? And you can see if these two both angles are 30 degrees, then it's a parallel line here to the base. Now coming to the next point, dependence of angle of deviation on the material of prism. Yes, if you have used a denser medium, then the deviation will be more, and then it will bend more, and if it bends more, it means the deviation will be more. So if you take an example of, the refractive index of flint is more than the refractive index of clown. So it means the angle of deviation will be more in this case. It is found for a given angle of incident, the prism with a higher refractive index produces a greater deviation than the prism which has lower refractive index. Simple. So this will produce a higher deviation. This deviation, okay, flint here is more than deviation in, say, crown here. Is it clear? Now, very simple. There's nothing to do about that. Dependence of angle of deviation on the angle of prism. Yes, we have mentioned here angle of incidence. If angle of incidence is angle of prism is more, then the deviation will be less, because you are subtracting that part from it. Got the point? If it is less, deviation will be more intense. Okay. So take an example here. It says it is found that the angle of deviation increases with the increase in the angle of prism. I don't know how they are saying here. Give me 1 second. It doesn't look like, because if it is I1, I2 is fixed, angle of incident, angle of prism will be more. It is found that the angle of deviation increases with the increase of angle of prism. So it means that when we increase angle of prism, although it is being subtracted here, right? So deviation will increase. anyhow we have to take it whatever they have mentioned in the book. I believe, okay, logically when I applied, it looks like if we increase this, this will decrease because we're subtracting this from this one. So anyway, it is found that, okay, it has been mentioned somewhere, this is a star here. Why is it so? It is found that angle of deviation increases the increase in angle of prism here. So remember, if A increases, then deviation also increases, like that. Dependence on angular deviation on the color of the wavelength of light. Okay, we know that red has got bigger wavelength and violet has got smaller wavelength, right? So bigger wavelength will have higher velocity, it will have a lower velocity, fine. So if it is higher velocity, it will have a less bending power and it will have more bending power. More, it will bend more, right? So if it bends more, it means it will deviate more. So it says violet here will bend more as compared to red. Means the deviation in violet is more than the deviation in red here. As simple as that. Because the refractive index of violet is more than the refractive index of red here. And you know the reason. Basically it talks about wavelength, more wavelength, bigger velocity, higher velocity, and higher velocity means less deviation. Smaller wavelength, small velocity, and higher deviation in it. Okay, this is how that we have all of these. Now we will be doing the numericals on it. I just gave you the introduction part once again. Why? Because we will be using these formulas to solve the numericals in it. So one thing just I want to clarify. Earlier I mentioned that deviation will increase with the decrease with the increase in angle of prism, but no, that is angle of deviation will increase with the angle of increase in the angle of prism here. Okay, that's it, everything is the same. So fine, let's in the next video I will be talking about the numericals.